Again, looking at compound events where we want, where our simple event is something or something else, but we want to make sure we don't, there can be some overlap, there can be an intersection of the two things that we're looking for. So we'll use this as problem number 4 as an example. A decahedral die, that's a 10-sided die, there are 10 faces. Include all counting numbers from 1 through 10. Consider the die when finding each of the probabilities in problems 1 through 4. So problem 4 says we want the probability of rolling an odd number or a prime number. And we learned in class today that the way you would find this would be to find the probability of an odd number plus the probability of a prime number, and then subtract the probability of getting a number that's both odd and prime. So the probability of an odd number, well, every other number is odd. Let me just make the sample space for the whole die. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The odd numbers are 1, 3, 5, 7, and 9, which is 5 out of 10, so that's 5 tenths. The probability of a prime number, the prime numbers would be not 1. Don't forget, 1's not prime. The prime number has exactly 2 factors, 1 in itself. 1 has only 1 factor. 2 is the only even prime number, is the smallest prime. 3, of course, is prime. 5 is prime. 7 is prime. And that's it. So that's 1, 2, 3, 4 tenths. Then we want to subtract the probability of a number that's odd and prime. The ones that are odd and prime would be 3, 5, and 7. So we're going to subtract 3 tenths from that. So we have 9 tenths minus 3 tenths, which is 6 tenths. The reason you have to subtract it, if you look at a Venn diagram, if we want odd or prime, the intersection would be the ones that are odd and prime, 3, 5, and 7. And then we would have 1 and 9 out here and 2 over here. So the number of favorable outcomes, you can just count them now. 1, 2, 3, 4, 5, 6 out of 10 possible outcomes. So you could make a Venn diagram and then just use the definition of probability and say favorable over possible to get there directly. But sometimes it's easier to just find the probability of each one and then subtract the intersection, because if we do probability of odd plus probability of prime, we're counting this 3, 5, and 7 twice, and we don't want to count them as favorable outcomes twice because they each just represent one favorable outcome. I should have, by the way, simplified this to 3/5. Okay, the other problem I want to look at is the one with the word tiles. Like if you're playing a Scrabble game, you have, of course in Scrabble you have more than 26 letter tiles, but let's just pretend we only have 26 letter tiles, one for each letter of the alphabet, and let's consider Y to be a consonant, not a vowel. We want the probability of pulling a tile and having it be a vowel or a letter in the word move. So try to find that compound probability during the pause and then come back and compare your work to mine.
Paused.
This would be equal to the probability of a vowel plus the probability of MOV or E minus the probability of a vowel and MOV or E. This is the easiest one to find right away because there's only 2 vowels in the word move, so that would be 2 26ths. We're subtracting that from the probability of getting MOV or E would be 4, because none of those letters are repeated, 4 out of 26. and the probability of getting a vowel, A, E, I, O, U, there's 5 vowels out of 26. So we would have 9, I said 26 here and I wrote 24. We would have 9/26 minus 2/26 is 7/26. Basically, A, E, I, O, U, M, or V will be a vowel or a letter that's in the word move. Okay, I hope that helped with the homework. I'll see you tomorrow.